The argument between diesel and gasoline engines has been a popular topic in the automotive industry for years. As consumers and producers consider the benefits of each fuel type, issues such as longevity, efficiency, and environmental effect come into play. To determine whether engine type may have a more sustainable future in the automotive industry, this comparison is essential. Here are 7 key points that highlight the differences between diesel and gasoline engines, particularly regarding their longevity and overall performance. Longevity of diesel engines. Diesel engines are well known for their remarkable lifespan, frequently outlasting gasoline engines by a significant amount. The main causes of its endurance are diesel technology's intrinsic operational and design features. The compression ignition concept used in diesel engines necessitates sturdy construction in order to endure the high temperatures and pressures produced during combustion. Cast iron and high-strength alloys are 2 examples of materials used in diesel engine components that are chosen for their resilience to harsh environments. To survive the extreme stresses generated during operation, many diesel engines, for instance, are built with reinforced cylinder blocks and heads. Because of this, a well-maintained diesel engine may often reach over 500,000 miles, and some heavy-duty applications have been known to have lifespans of over 1 million miles. Engine design and durability. Diesel engines' performance and longevity are greatly influenced by their engineering and design. Diesel engines use compression ignition, which entails compressing air to extremely high pressures prior to pumping fuel into the combustion chamber, in contrast to gasoline engines that use spark ignition. Because of the high heat and pressure produced by this process, stronger materials and parts are required to avoid mechanical failure. Additionally, diesel engine components, such as cylinder heads, are typically larger and reinforced to handle the stresses associated with high compression ratios, often above 20:1 compared to gasoline engines that usually operate at lower ratios, 10:1 to 12:1. Diesel engines also have more advanced fuel injection systems, which ensure effective fuel atomization for ideal combustion by operating at pressures up to 30,000 psi, which is far higher than those of gasoline engines. Fuel efficiency. One of the strongest arguments in favor of diesel engines over gasoline engines is their fuel efficiency. Because diesel fuel has a higher energy density than gasoline, about 130,000 British thermal units per gallon, compared to around 115,000 British thermal units for gasoline, it contains roughly 10 to 15% more energy per gallon. Because diesel engines have a higher energy density, they can produce more power per unit of fuel used, which leads to much superior fuel economy. Many contemporary diesel vehicles have fuel efficiencies that are 30 to 35% higher than those of their gasoline-powered equivalents. This enhanced efficiency is particularly advantageous for long-haul trucking and commercial fleets, where reducing fuel costs can lead to substantial savings over time, potentially thousands of dollars annually per vehicle, depending on usage patterns. Operating conditions. In contrast to gasoline engines, diesel engines are especially made to run efficiently in a variety of environments while maintaining lower RPMs. Applications needing continuous power output without putting undue strain on engine components must have this feature. Compared to gasoline engines, which frequently run at higher RPMs of 3,000 to 6,000 RPM, diesel engines suffer from substantially less wear and tear on vital components like pistons and bearings, since they operate at lower RPMs, usually between 1,500 and 2,500 RPM. Compared to gasoline engines, which require higher revs to produce comparable power outputs, they can produce maximum torque at significantly lower engine speeds due to their lower operating speed. Maintenance requirements. Diesel engines offer a special situation in terms of maintenance needs that can be both beneficial and difficult for owners. Over their lifespan, they frequently need less frequent repair than gasoline engines, despite the fact that their more complicated components, such as intercoolers and turbochargers, may result in greater initial maintenance expenses. In contrast to the conventional 3,000 to 5,000 miles that are advised for many gasoline engines, contemporary diesel engines can run for up to 7,500 miles or longer between oil changes. Diesel oil's higher lubricating qualities and the fact that burning diesel generates less carbon buildup than burning gasoline are the main causes of this longer interval. Additionally, diesel engines typically have fewer parts that are prone to wear, and failure over time because they are constructed with stronger components meant to withstand high pressures and temperatures. Compared to their gasoline equivalents, diesel vehicles typically require less repairs overall, while some maintenance procedures, such injector servicing, may be more expensive due to specialized parts or labor requirements. This lower frequency not only saves money, but also eliminates downtime for repairs or servicing, a vital element for firms reliant on operational efficiency. Torque and power delivery. Diesel engines differ from gasoline engines in terms of performance delivery and application-specific usability due to their torque characteristics. Diesel engines' design and operation are based on compression ignition technology, which allows them to produce noticeably more torque at lower RPMs. This implies that they can provide maximum power without needing to rev high, a significant benefit when starting from a halt or when carrying large loads. A typical modern turbocharged diesel engine can achieve similar performance at much lower speeds, around 1,500 to 2,000 RPM, whereas a gasoline engine may need to reach higher RPMs, 3,500 to 4,000, for optimal torque delivery during acceleration or towing scenarios. This capability enables diesel-powered cars to accelerate smoothly even when loaded and to provide improved control over difficult terrain and steep inclines without unduly taxing the engine or transmission system. Because of this torque advantage, diesel-powered vehicles are especially well-suited for tasks where reliable power delivery is crucial for efficiency and safety, such hauling trailers or moving big objects. Environmental considerations. Environmental considerations have increasingly influenced consumer choices in recent years, especially with growing awareness about climate change and air quality issues, leading manufacturers to invest heavily in advancements in diesel technology aimed at reducing emissions while maintaining performance standards. Historically criticized for producing higher levels of nitrogen oxides and particulate matter, modern diesel engines have seen significant improvements through the integration of advanced emissions control technologies such as selective catalytic reduction systems and particulate filters that capture soot particles before they exit the exhaust system. SCR systems work by injecting a urea-based solution into the exhaust stream. This reacts chemically with NOx emissions at high temperatures within the catalyst converter system, converting them into harmless nitrogen gas and water vapor. Furthermore, particulate filters capture soot particles produced during combustion processes. These filters need to be cleaned or replaced on a regular basis, but they greatly reduce the total amount of emissions that modern diesel vehicles release into the atmosphere when compared to older models that do not have such technologies. In summary, diesel engines are expected to last longer in the auto industry due to their robust design, fuel efficiency, and lower operational wear compared to gasoline engines. Thanks for watching our video, and don't forget to subscribe.